Go.
Thanks.
Welcome back. We are with Mads again. Welcome back, Mads. Again, you can already read that, how AI is empowering researchers. Here we go, what to say from CACTUS. Over to you, Mads.
So for those of you who didn't hear me on the fireside talk this morning, I am the VP of products at CACTUS Labs. Right now I'm part of a team in Denmark. We were recently acquired by CACTUS Communications, and we're active in the academic publishing industry. We're providing services to authors, researchers, and to large publishing houses of academic content. So I'm just going to give you a couple of headers on the kind of person I am, so you know where I'm coming from. I spent my 20s, which was the 90s. I'm that old, doing games, and actually what interested me about games was the dynamic character of these systems, the real-time systems that you could deploy. And we actually were working with machine learning already back then, when we didn't dare to call it AI. I was also in California for a number of years, and I was head of product at Siri. And before you ask, of course, this is the first sort of digital assistant that was, we were bold enough to call this an assistant. And before you ask, is it AI? Is it really cognizant? No, well, it's just a very, very smart system that we spend a lot of time, a lot of gifted people spend a lot of time producing this product. The team that I'm part of, we spent 8 years building tools for researchers and publishers, and we've been working with leading publishers, academic publishers, for the last 6-7 years. We're now part of a larger family of CACTUS Communications, and we're really, really happy to be able to reach a much larger audience. I'm going to give you a couple of examples of the sort of menial things that we do with AI. You probably know users who bought this also bought that from Amazon. So these recommendation systems are also common in academic publishing. Here you see on almost every book page and an article page in the research community, you see these suggestions on the side. And what we can do is we can recommend you things that are basically about the same thing. And you think that's pretty easy. You just do some overlap, some of the same words, etc. But it's actually somewhat more complicated than that. First of all, you always have cold start problems. The interesting articles to recommend to a researcher who reads this article are articles that are about the same thing, but we can't just recommend other articles read by people who read this article, because when an article is just published, the first day there'll be no other visitors to that article. And the first day is actually when that article is most important to push to people who are interested in that content. So that's where content similarity comes into play. And oftentimes people don't use the same words to describe the same things. So we have to understand exactly what the word means and which words mean approximately the same thing. We've also been tasked to solve one of the key problems in the publishing industry, that are what 5 keywords to attach, or I guess we only have 4 here, what 4 keywords to attach to an article when you publish it. So you may not believe this, but this is one of the key elements of the business model of academic search. Private companies often subscribe to topics, and they don't really pay for all of science. They just subscribe to the topics they're interested in. And the keywords assigned to a particular piece of content really determines who gets access to it. So it's incredibly important that these keywords are picked intelligently. And so we worked on annotating all of the Springer link content with these keywords, and in the process found out that in fact the quality of the keywords that humans provide is really, really bad. We also power the largest Nano science portal in the world. This is nano.nature.com, and we use AI to explain to a user why a given result after a search is particularly interesting to them. So in this case, if a user searches for a particular compound, we can say that in this article, we discuss this compound with these particular other things. And then we are building products that popularize the access to AI technology. This is a tool that we built for publishers that allow them to repackage, basically collect content around a particular topic, and then resell that as a package. So an alternative, if you can say that, to the keyword selection that I described earlier. So this is a tool so simple that even marketing can use it. And here you basically type in some keywords or select some example content, and then we select other content that's similar. This tool is being used actually to amass relevant content around the SDGs. So all of UN's content is actually ordered along the SDGs, all their publications and reports, using the tools that we develop. And you can find that at the OECD website. Our tools are also being used by large medical publishers to help them surface new content in a particular area. Here's BMJ. They have built a topic portal where each of the topics are powered by our technology. And the fact that this tool is so accessible means that you don't have a ton of intervening actors or computer programmers sort of diluting the process between making an editorial decision and seeing the results in the wild. We've also powered, and this is, I think, the last example, the reviewer selection process. So all of science is built around peer review and making sure that really competent peers are reviewing the latest publications. And so when a manuscript comes in, one of the things that takes the longest time is actually to identify appropriate people with the skills to review a new manuscript. And so we're integrated with the largest automation system in the world for this, called Scholarone, and we're providing UI for the selection of reviewers and making sure that the assessment of reviewer quality is much better than it used to be. So how do we do this? Well, content similarity, that's this may be old news to some of you, but many years ago we used to build fingerprints of documents by looking at the rarest and most meaningful words and basically building a vector representation or a bag of words to represent that document. Then in the 2000s, especially in the publishing, academic publishing industry, there was this big surge towards building ontologies that describe the world, basically determining exactly what the right word is for a certain thing, and then setting out to map all of the world's scientific concepts. Of course, they failed miserably at this task because the new innovations and new knowledge makes it really hard to keep up with this, keeping this model of the world up to date, especially if you tend to spend all your life arguing about whether a tomato is a vegetable or a fruit. So in the 2010s, I guess we moved into more unsupervised systems, and today we're actually extracting features from all of the text that is submitted. So when we see a manuscript, we're basically using every single word in that manuscript to assess what is relevant and what is important and which other pieces of content are similar to this. And we're pretty good at that. So the good thing about cloud technology is that even small teams can compete with giants like Google and Microsoft. And because we have a particular focus on scientific content, we can actually outperform these monstrous giants. So where do we go from here? We're good at doing content similarity, but we would actually also like to help users create content. So we've seen Microsoft move slightly in that direction. They have this ideas bar in Word that allows you to restyle your tables and potentially correct spelling mistakes. But we would like to go one step further. We're not alone in this. Other companies like Grammarly and Rightful are trying to do the same thing. basically supporting content creation, not just in your Word editor or your document editor, but also when you're filling out forms on the internet or writing emails in Gmail or whatever email client you have. We would like to take it one step further. We have this idea that if you can do content creation using AI, like we know it from other domains, the visual domain, some of you may be aware of these tools that make it really easy to correct images. I guess this is not the nefarious use cases of fake news, but more in the realm of improving images. And we've seen also style transfer applied. And why should we be able to do the same thing for language? So here's an example. This is from a few years ago when Microsoft tried to build a very, very large probabilistic model to help us with communicating. This is technology that we use to build chatbots, but we're actually we're not that confident that chatbots can behave well in the wild because they're all probabilistic systems. So if you push them towards a certain direction, their models can tend to provide really, really bad output. So this is Tay. She's a Microsoft experiment from 2016. You can see the date there. This was March 23rd. Just when she started to interact with people on Twitter, she was trained on a lot of Twitter conversations, and then there are some really dark holes on the internet that you actually don't want to include in that kind of training. So it only took about 15 or 16 hours for Tay to start spewing all types of hatred, and this last tweet is about 5 minutes before she was shut down. So this teaches us that content creation using AI can be really, really tricky. Because all of these deep learning systems are essentially just big probabilistic models with a very small probability that they'll do something really, really bad. Here's an example from, I guess, one of the leading technologies in language models. So I'll just show you briefly what this can do because it's pretty amazing. So if you feed the system with an input like this, train carriage containing nuclear materials stolen in Cincinnati, its whereabouts are unknown, and then ask that model to complete with the most probable continuation of this sentence. It creates something like this, which looks on the surface like a reasonable description of what might have happened. This is similar to a news article. The content trained on was actually news materials. And if we look at the features in the input seed, you can see that train and controlled nuclear materials, theft, stolen, Cincinnati, and whereabouts is actually included in the output. And it's pretty remarkable that the model can have both short and long-term recall of these important traits. And it's even more remarkable that some of the other things that are introduced in the sentences are relevant to this. So just as a note, the downtown train line in Cincinnati actually has the two stations, Covington and Ashland. There's a reference to the US Department of Energy because they control nuclear substances. There's a mention of a Tom Hicks, and I went out and Googled him. It turns out that he was, in fact, Energy Secretary, not for the US, but for the US Navy. The University of Cincinnati has a research triangle park. It does not have a nuclear research center, but it's close enough. So this is indistinguishable, I guess, from real news. And of course, the people who developed this were also very careful to use that as a marketing gimmick when they launched it last spring. So what do we do with systems like this when they're remarkably unreliable? Well, we're currently building systems that help the author in the writing process. And we're trying to use and adapt these language model technologies to help the user when they get stuck. So here's a screencast of a user typing. And at some point, they maybe become doubtful about what they're expressing and whether that actually is a true depiction of, or the best expression of what they want to say. And we have a language model that's been trained on all of science, all of published articles in the world that can help them expand and explain what they're trying to do. And then some steering mechanisms that could help them regenerate this section to express what they truly want to express. And these are the kinds of products that we'll be seeing in the coming years. I think in many respects we're reaching kind of a tipping point where the technologies that we've known in image recognition and computer vision and all those features are now coming to language. It's taken a while for computers for us to develop the right algorithms to understand language, but we're just getting to that point where it's becoming incredibly possible to work with the real meaning of language. So you may or may not know this, but all of computer vision technology really took off about 10 years ago with the creation of ImageNet, a million image database with classified and tagged images. And that was kind of the start. From that, we saw the style transfer. Here you can see a photograph that you can maybe you can style like a painting by Turner or Van Gogh or Munch. We can transfer night styles onto images to make them look like they were taken at night. We can change the style of scenery in an apartment. We can create new tools that allow you to basically compose artistic output using the types of tools that we couldn't imagine 10 years ago. And other types of output that we probably also couldn't imagine 10 years ago. So here's another fun example. I don't know if you managed to see this while it was live. So there's this guy in Holland who trained a deep model to reconstruct photos from line drawings. He basically showed it a lot of line drawings or examples of line drawings and the corresponding photograph. And that allows you basically to do a line drawing and then have an approximate photograph generated. And that's of course pretty funny to play with, especially when you start to draw strange objects like these. But you may struggle to see what is the business application of this. Other people have struggled less to find more nefarious applications. This is some of the other things that we can do with this technology. So we're, I think, facing a whole era of lacking trust in the pictures that we're watching, and soon that same problem will come to text and to language. Of course, there are also less nefarious applications, and augmented reality and ways that help us provide services much faster and at a lower cost is probably a more positive depiction of this. But what we need to remember, though, is that these deep learning models, while they're incredibly impressive, I remember when I first saw this. This is a Google algorithm that can tag and write down depictions of what is on an image. I was incredibly impressed. But what we need to remember is that this is not really understanding in the way that we think about intelligence or understanding in humans. So here are other examples of things that most humans would recognize as failures. And no one, I think, in their right mind would ever park an airplane like that. And when we had thinking machines, this is also, I guess, going on 10 years ago. This was 2011 when Watson won the Jeopardy championships. This was not the end of history. We don't have thinking machines that think like humans do. We have AI that is very, very good in some narrow verticals, but we don't have any general intelligence, and we're not, in my opinion, likely to have it anytime soon. That doesn't mean, though, that we don't imagine having it. We think we know AI from the movies, but the reality of AI is slightly underwhelming. AI is the technology that allows you to speak to your phone, or the thing that means that you don't know why your house loan was rejected. It's the thing that allows you to lift your hands off the steering wheel, or the thing that allows us to kill people from a long distance. So what is the role of humans in this new world? When I grew up in the 70s, we used to have chess on TV. we saw like the big grandmasters from the US and the USSR playing chess.
Sorry to interrupt, Matt. Just running out of time. Maybe you can just speed it up a little. And Ajay is also on stage to actually ask you a question. He's just waiting for you.
Okay, thank you. I'll round this off in a second.
Sure.
So the thing is, we shouldn't be afraid of new technology because we continually refine what it means to be human. We don't we're not sad that we can't run as fast as a horse. We sit on horses and then we go faster. And AI has always has some intent. When we design products, we build that intent into them. They don't run amok. They just don't go necessarily in the direction that we planned. And so we have to be really, really careful that we don't think of these systems as intelligent, but think of them as either smartly or less smartly defined. And one of the key things that I want to point you to here at the end of the talk is all the pitfalls and the ethical problems that we could see. So here in the top right, you see a soap dispenser that doesn't work if your skin is colored. We have many examples of bias in training sets, but fortunately, we keep forgetting that even when you have bias in training sets, that normally means that the current state of things are actually not that great either. So we had a lot of there's a lot of talk about the bias in the sentencing systems in the US, but we shouldn't forget that the reason that bias was there is because judges themselves are currently quite biased. So as long as we design these systems with an afterthought of transparency and fairness, we can make systems that are better than what we have today, even if we automate them. So let's watch out and not train on data that we don't understand. So there's some examples of products built by people who think that they can just plug deep learning onto some video and extract sensible features that make for selection of good candidates, for instance. Let's watch out for that, because when you have a large open world and you're trying to set objectives for training, then sometimes you have really strange emergent behavior. And so with that, I'd like to hand over the reins to Santosh.
Sure. Thank you so much. So you can unshare the screen and then join us on Image. Thank you so much. So over to you, Ajay. I think you have a question and then.
Sure. Yeah. Thanks, Santosh. Thanks, Matt, for not only this keynote, but also the earlier panel, fireside chat, whatever you may want to call it, that you did a couple of hours back. And I'd like to kind of pose a question, bringing the two together. So the role of humans in AI is something that we tried to touch upon not only in a couple of panels earlier today, but also when we were doing the road shows leading up to building up the summit. Taking that and your earlier session where you spoke about how ecosystems can be built and how research, academia, industry, governments can kind of come together. And given that your company, your organization, UNSILO, is now in collaboration with CACTUS Communication, there's already a Indo-Danish kind of collaboration there. What are the areas that you see, given strengths that the Nordics in general has around research in emerging tech and the kind of work that is happening in Denmark and the work that you do, you see that there could be potential to do more in the corridor between Denmark and India?
So first of all, yeah, we're now a part of CACTUS Communications. We were wholly acquired, and we're very happy to be part of such a large and influential organization. We're now the leaders in our field of services to authors and researchers. And I think I feel incredibly lucky that we're in a position where we can apply the skills that we have, not just for improvement of a particular set of skills or to find like the cure for cancer. I think when I get up every morning, I think that what we're doing is we're enabling researchers across the globe becoming more efficient and getting better at what they do, discovering relevant new knowledge faster, and in essence accelerating the pace of research across all fields. That's what we aim to do with our tools. We want to remove all friction and make research faster and more efficient. And I think we've always spoken about the intelligence explosion and about the growth of human knowledge and capacity as an exponential curve. But the most important part of an exponential curve is what's the doubling rate? How long time does it take to get inspired by new research and build on top of it? And I think that's one of the key problems that we aim to solve, to accelerate the pace of research. I think in the Nordics, we've built a really solid social welfare system that allows us to experiment more. One of the things that is a prominent problem, both in the US and from what I know of the developing world also, is that there's so much at risk, and it's so difficult for people to make that decision to become an entrepreneur or to do something out of the ordinary, that when you're in a welfare state like Denmark, it's so much easier to bet on something that you believe in, because you're not risking the health of your family. And I think that's one of the things that allows Denmark to innovate sometimes at a much greater pace.
Sure, then. Thank you. With this, we have to end this session right now. So by Mads, how AI is empowering researchers. Thank you so much, Mads, for being out here. And then, of course, the audience, you know how to applaud. I don't want to say that again. Thank you so much, everyone. We have some interesting session coming up next. I think Ajay will put up a light before that next, immediately in a minute or maybe 2 minutes time, because we have 5 AI product showcase happening. Very encouraging or very interesting ones. I have been part of it, so I know sneak peek of what it is. So be out there, hang around, and then after that, you have something more, special, which Ajay is going to mention right now. Yes, Ajay. Can you just inform me?
Yeah, so just like Santosh has mentioned, we did 5 startup showcases last week. We are doing 5 today. And the special announcement that Santosh is mentioning about is something that we have been looking forward to, and we hope that a lot of people in the audience as well, is the release of the India AI landscape report, which has been in the works for a few months. I'll not kind of disclose more because Jagruti is going to be making the announcement or talking you through the report, has a fair bit of slides to run you through. So that is the big announcement that Santosh wanted me to kind of make. So thank you.
Sure. Thank you so much. Thank you, everyone. Thank you, Mads. We'll see you soon again. Okay. Thank you, everyone.